All right, welcome. So, it's an exciting time to be a senior, right? This is it. This is the final countdown of your classes. So we are in the 7th to the last class. And we are going to be doing a lab today on the cartridges in ballistics. And then on the next class on Friday, we're going to be analyzing the bullets. So please go over to campus. There's a file for you to grab, and it is called Ballistic Notes in Cartridge Lab. So we're going to go over how you analyze the cartridges. Set up around the room are dissection microscopes, and we are going to be going at a detailed look at the 4 or 5 markings that are imparted on a cartridge. So on the last class, we looked at catching killers, ballistics, and you learned that a bullet coming out of the barrel of a gun can be tied to the weapon, and that is really described as the fingerprinting of guns. I mean, it's that accurate that it can ID a particular murder weapon used at the crime. And then if they find the owner or their DNA or gunpowder residue, all this evidence then will add up to, hey, they were the shooter. So the fact that it's their gun doesn't mean that they pulled the trigger, but then they take it from there, and there's other forensics that you can apply to that. Sometimes they even leave their fingerprints on the bullets as they put them into the gun, unless it's in a magazine and it's already preloaded. So open up your notes. Looks like this, and I'm going to click into the textbook and show you a few things, but I've also got the notes already built out, so we're going to go over it more or less kind of like a slideshow, but then I'm going to touch upon the actual textbook and show you a few things. So I've got mine. It does tell you to open it up. It says open it up in Pages. I think you're okay if you open it up in Notability, but if you open it up in the word processing program of Pages, then it can expand as you need it to expand. In today's lab, you will be adding pictures, so it just helps you not be tied into the format of a PDF file. So you do have the option, even though it says open it up in Pages. So these are the notes from the textbook. If you were to click on the textbook, perhaps you could do it side by side if you want to do a split screen, but you are to answer the questions really for our pre-lab. So firearm identification centers on studying the marks imparted from the weapon onto the bullet and onto the cartridge. It's called the shell casing. The shell casing has the explosive in it, so it is going to propel the bullet out of the barrel of the gun, and the bullet is actually smaller than the diameter, larger than the diameter of the actual chamber of the gun, and so it takes that explosion to push it through. And there are markings on the inside of the barrel that are going to spin the bullet, as we learned in the last video. And so without the bullet being wider than the barrel, it wouldn't impart the spin on it. So it's slightly wider, so you wouldn't be able to drop the bullet in to the end of the barrel. So you're filling in the blanks. Firearm identification centers on studying the marks on bullets and shell casings to determine if these were fired from a specific gun. We learned of the term rifling on the last class. Rifling is these marks inside the barrel There are high points inside the barrel, and they will scratch grooves inside of on the side of the bullet. And really, what it's doing is it's spinning the bullet. Because just like throwing a football, it's going to go through the air in a more true trajectory. If you know about baseball, one of the hardest pitches to throw or to hit, it's called a screwball. It doesn't have any spin to it, and so it's going to fly unpredictably based on maybe the wind between the pitcher and the batter, and it acts erratically. But if you have a spin on a trajectory like a bullet, then it's got a path that it's going to follow. Makes it more accurate. All right, next question. When was it generally accepted by law? Really interesting video on the last class, wasn't it? The first use of forensics ballistics was in 1915. And so that's what it means by the early 1900s. So you could say 1915 was the first time it was used in a court case. Wasn't it also interesting that that expert at the time was viewed as an expert, but he didn't even do his job. He faked his results. And it sent someone on death row after the guilty verdict, and then they looked at it again because this guy kept professing his innocence. And then they brought in some additional experts and figured out that, hey, he didn't even examine the bullets correctly. So by 1930, along with the creation of the FBI in 1932, now this is a standard forensics practice in ballistics, analyzing weapons. Question number 4. Let's see, was that, yep, I guess we're on question 4. What's the name of the database? IBIS. That stands for Integrated Ballistic Information Network. System or network. So if it's NIBIN, it's very close to IBIS. So Integrated Ballistic Information System. And if it's IBIN, it's network. And if it's got an N in front of it, it's national. So they're all very similar. And who runs this? 2 agencies, the ATF and the FBI. Sometimes the ATF is called the BATF, but on their hats and on their shirts they abbreviate it ATF, Alcohol, Tobacco, and Firearms. It's another division of our government. So that's really the answer to question number 5. So you can see right here I say C number 4 for the answer for who runs it, because I combined it in number 4. We'll come back and watch this internal ballistics video here in just a minute. So we'll skip number 6 and come back to it. And we'll jump down to number 7. So they sure can pinpoint the bullet to the gun, but how do they tie the individual to the gun? And that is with gunpowder residue. As the bullet is exploding, it really is like a bomb inside of the cartridge. And it's exploding in all directions. And because of that, it also pushes the bullet casing backwards, propels all of the gases and stuff out of the barrel because it's the only place for it to go. All the residue from the explosion is called gunshot residue. And this could really help to determine what happened at the crime scene. So the residue gets pushed out quite a distance. So the distance from the gun that it was fired, it can help determine how far the target was from the gun that went off. So if someone is holding the gun and they fire it, they've got a lot of gunshot residue on the shooting hand. If they have a bystander, an accomplice standing right next to them, they're going to have gunshot residue on them. And it will go to about 10 feet. So they are going to determine by the amount of gunshot residue, really recreating where people were standing. They can determine if someone was shot with the gun right to their body, like in a suicide with the gun right up to their head. They can determine that with the amount of gunshot residue, or right on a shirt. And the same thing with their distance from 3 feet, 5 feet. So the amount really helps to determine how far they were from the shot. It can corroborate someone's story saying one thing and then the gunshot residue telling another one. So I guess I already explained this second question here underneath gunshot residue. The gunpowder particles surround the hole for the bullet. So when we go to the textbook, you will see what I mean by the distance and the halos and the amount of powder and stuff left right around that hole. It helps to determine how close or far away that the firearm was when they pulled the trigger. Gunshot particles and residue surrounding the bullet will provide information for how far away the gun was. Let me know if I'm going too fast. So how do they match up a suspected shooter? They'll always collect their clothes. So when they have them in custody, that becomes evidence, and that is going to be confiscated quickly so that they can analyze it nice and slow in the crime lab. Once they determine how much residue is on there, and if they have the actual murder weapon, they'll do test fires into other clothing and say, based on this weapon, this is how much residue is put out by it at this distance. And they'll match it up and say, yeah, they were 7 feet away when they shot. No, they were 3 inches away. So that really makes a difference in recreating a crime scene. So the blank on number 3 is their clothes, and making comparisons and test samples from the actual gun used to commit the crime. So now I'm going to go over to the textbook and we will look at the gunshot residue from 12 to 18 inches, 25 to 36 inches, and at what distance is there no gunshot residue. So I'll show you those pictures in the textbook. And I will also show you the 2 chemical tests that are performed for gunshot residue. And how do they test for primer and gunshot residue from a victim? Once they have them in custody, they have a way of getting the residue off of them, so I'll show you that. So that's as far as I'm going to take it with the notes when I get over there, and you are going to answer question number 8 and the 9, I guess it's 10 different questions. This is part of your homework. It's part of the lab write-up. It's in advance of what we're going to do in the next class. So I'm not going to go over the bullet identification with you. That's up to you to look at it in the textbook. So I'm skipping over that. I am going to show you question number 9. So in today's lab, you have to take a picture of the cartridge. That's why you have these microscopes. They're dissecting microscopes. And you have to take a close-up picture of it. You might be able to take a nice picture just with your iPad or with your phone without the microscope, but you could also take a picture right through the lens and you'll get a nice enlarged picture. If you're taking it with your phone or iPad, just right there on the desktop, please enlarge the picture, crop it so that I don't have 98% table and a tiny little cartridge sitting on the table. You have to be able to see these markings. I'm going to show you pictures of what they look like in the textbook, and make sure that you are submitting really good pictures. It's going to take at least 2 pictures because you need the back of the cartridge and you need the side of the cartridge. It's possible that you could have it take a picture at an angle like this, but you'd want to make sure because you're graded on identifying these marks. And if the picture's too small and you're doing arrows to it and saying it's this and that, and if I can't see it, then it has to be clear like the pictures that I'm going to show you in the textbook. So for your lab write-up, you're going to be looking at the cartridge specimen, and I've got them in this little box right here. And also I have a rifle barrel. And I've only got one rifle barrel right here, and you have to take a close-up picture of this, and you are identifying the rifling pattern. So the pattern is that it's going to the right or to the left. Okay, in the next class, you are going to count the number of grooves in the rifling pattern. You don't have to count the number of grooves. We're only looking at a half pipe right here. So just realize that I could ask you how many grooves are there. And if you counted them right here and multiplied it, you'd probably be right. But we're not going to go off of that. You're going to do it off of the bullet in the next class. But you need to tell me the rifling pattern, and that if you want to make a note for yourself, write down, is it a right rifling pattern or is it a left rifling pattern? So you can take your finger and you can rub it through here and you'll be able to feel which way it's going to twist the bullet, if it's going to twist the bullet to the right or to the left. I will identify on here what the front of the weapon is and what the front and what the back is. So you'll go from the back to the front, okay? And then you're going to tell me what rifling pattern that it has. So now let's head over to the textbook, and we are going to be doing a few things as we skip through this. At the very top of the page, I have a link to the textbook chapter. This was question 6, right, with the video? Was it number 6?
You've got the side picture, you pull the trigger, and within an instant, there is a hole in the center of your target. We're able to see the end result of firing a gun, but what exactly happens inside the chamber? Internal ballistics is a division of ballistics that studies the combustion of propellant, the pressure developed, and the motion of the projectile along the bore of the gun. Internal ballistics is a very large topic and entails a complex physical and chemical process. When the trigger is pulled, the firing pin strikes the cartridge, causing the tiny amount of compound within the primer to explode.
Is this question 6? I don't have the worksheet in front of me. Okay, so it says, describe what happens when the cartridge is exploded. So when I show you a picture of the weapon, it has a firing pin. It's like a hammer, and it will strike the center of the cartridge in the back. When you look at it, it's usually silver. And this is a high sensitive explosive. They called it a primer. So we skipped our forensics of explosions, so we're covering some of the basics right here. If this was a bomb, it would have a primer. So a cartridge has a primer. It's a very highly sensitive area that can explode easily. You could, and I'm not going to condone this, don't do this, don't try it at home. You could drop a cartridge, and if it hit just right, it would make the bullet go off. You could take a hammer and strike the back of it, and it would go off. It's sensitive. So you can't have kids playing with live ammunition. So you can see from this picture that the primary explosive is going to ignite the secondary explosive. So put that in your notes for question number 6. How does this work? So the cartridges are pretty big. They're filled with 2 types of fuel, a small, tiny amount of primary explosive, which is going to ignite the secondary explosive. And now you have a bomb. It's contained inside the cartridge, and the bullet is riding at the top of it like a rocket ship. And it only has one direction to go. The explosion is going to go in all directions, but the bullet is already in the back of the weapon and tightly enclosed in the chamber, so it's exploding to the sides, to the back, but most of it goes out the front.
This explosion burns the propellant, commonly smokeless gunpowder, causing a buildup of gas inside the cartridge. As heat and pressure increase from the burning powder, the rate of combustion increases. When the pressure exceeds the amount of friction holding the bullet in place, the bullet will begin to move. Once the pressure is high enough, the bullet is shot into the bore. Rifles and handguns have grooves cut on the inside of the bore called rifling. Rifling enables the bullet to spin as it accelerates through the barrel, which contributes to accuracy. Bore and rifling measurements are specific to caliber, which is why it's always critical to use the correct ammunition. As the bullet travels down the barrel, the pressure behind it begins to decrease, but not completely disappear. When the bullet leaves the muzzle, the pressure from the gas expands dramatically, creating a pressure wave in the air which causes a loud bang. At the same time, the pressure causes burning powder to be expelled with the bullet, which creates the muzzle flash. For Firearm Science, I'm Jessie Duff. See you next time.
So that is described right up here, and we're looking at the cartridge and what happens after that has fired. So there's the primer where the firing pin of the weapon will strike, and the bullet is just riding right there at the top. So most of it is the cartridge filled with fuel, and the bullet is only right up there. So a lot of times the casing is left right there at the crime scene because the cartridge is not left in the gun. It usually is going to be ejected automatically by 2 mechanisms, and we're going to talk about that. And these are the marks that you're looking at. So we're looking at the inside of like a 6-shooter here, and there's the firing pin mechanism right up here. And the breech face really is right here where the bullet will be resting. So we'll see a better picture of that in a minute. So there's quite a few pictures in here for you to take a look at. And this picture shows all of these things labeled here are going to leave marks on the cartridge. So you'll see a hammer mark from the firing pin that struck the back of the bullet. The cartridge is exploding in all directions, gets shoved back onto the breech face right here. That's just the metal where the back of the cartridge will get slammed up against. So any mark that is on that breech face gets imparted on the back of the cartridge. I'll show you some examples of that. Now the cartridge is sitting there inside of the barrel, and it takes two mechanisms to get it out. The first one is the ejector right here, and the ejector is going to push the cartridge up this way so that it's not right in line like interior in the chamber. So this is it's metal, and it's going to leave a dent and a scratch on the side of the cartridge so you can see it. Now we're going over this because weapons have unique extractors and ejectors and unique hammers. So if they look at it, they'll be able to determine, especially with a trained eye, that yeah, this came from this weapon because that weapon has this type of extractor, ejector, and firing pin. So this is good class characteristic. Only when the bullet goes through the barrel can you really get individual characteristics. So it's much easier to identify the weapon with the bullet than it is the cartridge. But if they have a cartridge left at the crime scene, it really is a lot of good info for leads. If they know that they're looking for this particular weapon, then they'll go to all the dealers that are selling that and get their records, who'd you sell it to. Then they do a lot of legwork, try to track down everyone who purchased that, especially in that geographic area and stuff. So once the bullet is lifted, or excuse me, the cartridge is lifted up like that by the ejector, it is sitting there and it has to be flung out, and that's the job of the extractor. It's going to shove it to the side. So it usually happens pretty fast, like boom, boom. And so it goes up and then throws it out to the side. And all those marks, 4 different marks, are really easy to identify. So now I'll go down here. A lot of videos and pictures if you want to look at it. Shotguns don't have rifling. It's a clear barrel. You can't identify shot. It's actually little BBs. They do not get any forensic value on it to identify it to one particular gun. It's only rifles and handguns. So that's what shotgun looks like. It's used for duck hunting. These pellets here really spray out a lot and help to ensure that you hit the target. So if you ever eat duck that has been shot, they try to do a good job of getting the pellets out, but when you eat it, you have to eat nice and slow. There's a chance you could swallow some of that shot, and you don't want to bite down too hard. It can crack your teeth. In our next class, we're going to be analyzing the actual bullets themselves. So here's the cartridge, and this is just the bullet sitting right up at the top. The diameter of the bullet is going to match basically the diameter of the weapon, and so this is called the caliber of the bullet. You'll also weigh these on a scale, and sometimes they're the same diameter, so you go after how much metal is on the bullet. And then also you can see some of these are rounded at the top and some of them are square. So these are lead soft points. These are full metal. And this one, you can see how it's concave. This is a frangible bullet. When it hits the target, it's going to expand, just like in that video that we saw, into many different fragments, which will then impart more wounds on the target. So it's meant to make more damage. Much better to get hit by a full metal jacket, which is maybe going to make a clean hole, versus a hollow point, which is going to basically explode. So that's our next lab. We'll look at those. So now here are some pictures of what you are going to see. See the indentation right there? That is the firing pin. Sometimes it's circular. Sometimes it is kind of oblong. So they do have different shapes. This is our next class. So firing pin circle, this one, it's got a different shape with another mark on the inside. So you will basically get a lot of info and you'll see that. So there's more markings for cartridges. I do have one other file that's going to show you more pictures. So that's all they have right here. So let's go down to the question where it said about the gunpowder residue distance. I forgot the number that it's at. So what does it look like if it's 12 to 18 inches away? That was one part of the question. And you're going to write down between 12 and 18 inches. That there is a halo of smoke around the bullet hole. There's a halo of smoke around the bullet hole. So here's 12. So you see the halo right there, and there's the bullet hole. If you get closer than that, you have a huge amount of gunpowder residue. So they have 2 inches. There's contact, not much because it's all centered right there, right by the bullet hole. But if you're a little bit farther away, 2 inches, then you got a lot of gunshot residue. 4 inches, 6 inches, and now you're a foot away from like right here, and there's still gunpowder residue. So you have a halo of smoke. So once you get close to 2 feet away, you lose the halo of smoke around the bullet hole. So what about 2 feet to 3 feet away? You'll see specks of unburned powder, because the unburned powder has more weight and it got thrown instead of dissipated and fanned out with powder. So even at 3 feet away from the target, you will have gunshot residue as scattered specks. So if you're more than 3 feet away, there's no gunshot residue that can fly 3 feet away. Everybody good with that? Ready to move on? There was another question that we skipped over. What are the tests that you can use? So here they are. The first one you can write down, it's called the grease test, G-R-E-I-S-S. It's a chemical test. They're looking for the presence of nitrites. So a chemical analysis. What question are we on for the tests? What was it? 7? Question 7. The first test is the grease test, G-R-E-I-S-S, and they're looking for the presence of nitrates. The second test for you to write down in number 7, it is looking for the presence of sodium. I guess it's pronounced rhodizonate. And they're looking for lead residue. So if you are a chemistry background and working in a lab, you understand the chemical reactions, and they are adding chemicals to get different reactions of the chemicals, and then they're going to get the indicated color off of this chemical reaction. So it's a presumptive test, and they'll follow it up with a confirmation test with hydrochloric acid. And it's interesting that the presumptive test is going to show a pink color with the chemical reaction. They followed up with hydrochloric acid, and the pink turns blue, and then lead is confirmed. Is it question number 8? How do they get this off of an individual? 2 ways. They're going to test for the primer residue on a person by putting tape on them. So they'll just put tape, and the residue will be then stuck to the tape. Or they're going to take a cotton swab, and they'll swab their hands with a little bit of nitric acid soaked into the cotton, and it helps to absorb the gunshot residue, so they get a good transfer onto the cotton swab. So when you're watching these TV shows and they have someone in custody, they're going to take their clothes so they can test it for gunshot residue. They want to check their hands, and you'll see them usually with a cotton swab, but taping is also the other method. All right, so we're almost done. Over here at Canvas, it says right here, you opened up this one as you are writing on it, but there's another file that says you can help you with your ballistics information. So I'm going to open this up, and I already have it over here at Notability, and I combined the two, but don't turn in all of these. It would be too big of a file. I combined it. So I want to show you some of the markings that you're going to be looking for. So give me just a second. I've got to find the cartridge instead of the bullets. All right, here we go. So it's on page 42 of that document, and you are going to be looking at these 5 different marks. So what do they look like? There's the firing pin. So when you take a picture of it, there's a marking, and there's another marking, and so on the back of the bullet, there are 3 marks that you can identify. The firing pin, do you see these parallel striations? It used to be smooth, but after it got slammed against the breech face, it imparted the pattern on, this is the breech face right here. You can see how it's kind of got these parallel vertical lines, and they got squished into the soft metal on the back of the cartridge. These are called breech face marks. They're very unique to the breech face of the actual weapon. I don't know if these two match up or not. You can have parallel or you can have circular breech face marks. So there's a better example right here. So you'll see that it will have parallel lines or it'll have circular lines, and so this breech face has circular pattern, and it helps to match up the weapon with the recovered cartridge. Usually cartridges are left at crime scenes. Different firing pin mechanisms. And now we'll go over to the extractor and the ejector. So the extractor has to extract it out of the chamber, and there's different mechanisms. They're made out of metal, and they're hitting metal, and they're going to scratch it or dent it. So I'll show you what those marks look like. The extractor marks are on the side of the cartridge. So there's the back of the cartridge, and you'll have to rotate it, and you will see either on the outer edge or usually right underneath that lip. And that's why the cartridge has that lip to it, so that the extractor can grab it and pull it out of the chamber. So you'll probably need at least 2 pictures. So you can see the extractor mark. These are 2 different types. So you're looking for these marks on the side of the bullet cartridge. It's on the rim of the cartridge case. The ejector needs to fling this out of the barrel after the extractor extracted it out of the chamber. Then the ejector throws it away from the gun. So right here you can see a good picture of it has been lifted up, and now this is going to have the last push to throw the cartridge away, and this mark is on the back of the cartridge. And so when you see a mark like that, that is the ejector mark. So you got the firing pin, you got the breech face, you got the ejector, and then the extractor is going to be on the side. All right, so now you can go to a lab table, and you are going to take a good look at it with the dissecting microscopes, get some good pictures. Yeah. So every table has a cartridge, and the rifle barrel is going to come around. So it's starting at table 8, and it'll make its way around.